Hi, for today's lesson, we'll be learning about the chain rule in calculus. The definition of the chain rule is if g is differentiable at x and f is differentiable at g of x and f is equal to f composed of g defined by f of x is equal to f of g of x is differentiable at x, then f prime of x is equal to f prime of g of x times g prime of x. This can be rewritten as dy over dx is equal to dy over du times du over dx. This is an example of what a definition will be given in a textbook. This may seem confusing. So when using the chain rule, we want to find the derivative of some function by using the two separate functions f and g. For our first example, we have y is equal to 3x squared plus 10, this term raised to the fifth. Now before trying to solve this, we can think of this as two functions. An inner function and an outer function. So one function would be 3x squared plus 10, and another function would be this inner function to the fifth. So in looking at this and using the definition, we have u is equal to 3x squared plus 10, this inner term. And our g of x is this inner term, a function. So g of x is equal to 3x squared plus 10. And our f of x is equal to g of x to the fifth, which this implies that f of u is equal to u to the fifth. Now that we have two functions, we can use the chain rule. So the chain rule was the derivative of a function is equal to the derivative of the outer function times the inner function times the derivative of the inner function. So the derivative of the inner function, g prime of x, is equal to 6x, and the derivative of this outer function is 5u to the fourth. So now, using the definition from above, we get that our f prime of x is equal to 5u to the fourth, which is the derivative of f of u, times 6x, which is the derivative of g of x. Multiplying this together, we get 30x times u to the fourth, which is equal to 30x times 3x squared plus 10 to the fourth, because our u, our inner term, was 3x squared plus 10. Now, because our original question was in y, our final answer must be in terms of y. So y prime, our first derivative, is equal to 30x times 3x squared plus 10. For our second example, we have h of x is equal to the square root of 9x plus 2. We can see right away that this may look like two functions could be used to find this derivative because we have this inner function, this outer function that's the square root. So this inner function, we'll call it u, so u is equal to 9x plus 2, and our g of x is equal to 9x plus 2, this inner term, and the derivative of g of x is equal to 9. F of x is equal to g of x to the 1/2. Now this is a square root, so this is the same as raising to the 1/2 power. And so f of u is equal to u to the 1/2. Using our derivative rules, f prime of u is equal to 1/2 times u to the 1/2 minus 1, which is equal to 1/2 u to the minus 1/2. F prime of x is equal to 1/2 u to the negative 1/2 times 9. We have to remember to bring this 9 down for our g prime of x. And this right here, again, is the definition of the chain rule. It is helpful to often write it when doing the problem. So now using this, we have f prime of x is equal to 9 over 2u to the 1/2. This u to the negative 1/2 means it can be brought down, the 1/2, and the 1/2 power is the square root. So our f prime of x is equal to 9 over 2 times the square root of u, and u is 9x plus 2, so f prime of x is equal to 9 over 2 times the square root of 9x plus 2. Because our original problem was in h of x, we write it in terms of h of x. So the first derivative of h of x, so h prime of x, this little tick mark is prime, means derivative. So h prime of x is equal to 9 over 2 times the square root of 9x plus 2. For our third example, we have the function f of x is equal to 3x plus 4 squared times x squared plus 15 to the fourth. We may see right away that there are definitely two functions. However, these functions are each raised to different powers, so the product rule must be used. So f prime of x is equal to the first function times the derivative of the second function plus the second function times the derivative of the first function. So we see here the product rule must be used to evaluate this derivative. However, within this product rule, we still need to use the chain rule. So we need to evaluate this derivative and this derivative separately before finding our derivative, our final derivative of f of x. So the derivative of x squared plus 15 to the fourth. Our inner term u is x squared plus 15, which is also our g of x, our inner function, is equal to x squared plus 15, and the derivative of g of x is 2x. Our f of g of x is equal to g of x to the fourth. So this implies that f of u is equal to u to the fourth, and the derivative, f prime of u, is equal to 4u cubed, because this is a power, so we bring it down and then subtract the power by 1. So the derivative of u to the fourth is 4u cubed. And now using the definition of the chain rule, we have our derivative of this term is equal to 4u cubed, f prime of u, times the derivative of g prime of x, which is 2x. This is equal to 8x times u cubed. U was this inner term right here. So our f prime of x is equal to 8x times x squared plus 15 cubed. However, we are not done because we still need to find the derivative of this term. So the derivative of this term, so the derivative of 3x plus 4 squared, we have an inner term of 3x plus 4. So our inner function is g of x is equal to 3x plus 4, and the derivative of g of x is equal to 3. Because we have a constant in front of an x, the derivative is just that constant. Our f of g of x is g of x squared. We see that there are two functions. We have an inner function, and then this function squared. So f of u is equal to u squared, f prime of u is equal to 2u, and then, so now using the definition of the chain rule, we have the f prime of x is equal to 2u times 3. This 2u is f prime of u, and this 3 is g prime of x. So f prime of x is equal to 2u times 3, which is equal to 6u, and f prime of x is equal to 6 times 3x plus 4. So now that we have both derivatives worked out, we can substitute these values back in to our product rule. So the derivative of x squared plus 15 to the fourth is equal to 8x times x squared plus 15 cubed, and the derivative of 3x plus 4 squared is equal to 6 times 3x plus 4. So now we just substitute this value in for here, and this value in for here. So f prime of x is equal to 3x plus 4 squared times 8x times x squared plus 15 cubed, plus x squared plus 15 to the fourth times 6 times 3x plus 4. F prime of x, our final answer, is equal to 8x times 3x plus 4 squared times x squared plus 15 cubed, plus 6 times 3x plus 4 times x squared plus 15 to the fourth. So the chain rule is a very important tool in evaluating derivatives in calculus. And to really understand the chain rule, we must understand that we are ultimately dealing with two functions to find the derivative of an overall function, which was in each of these examples. So I hope this helped you in your calculus course and in understanding the chain rule, and thank you very much for watching.